How we doing? Pre-calculus 12. Hope you're having a great morning. I'm just so grateful today. I've got a lot of people at my study session. Look at everybody. You know? I know you're sleeping in. I hear you. I hear you. 7:15 in the morning. You are ready to go. I hope you're having a great, a great morning. Hopefully, as we prepare for this thing, I hope that some of this stuff will help you. We're going to go straight off the review, okay? And we're going to hit on just a couple of problems as we go down. I'd like to start off with some of the ones that maybe be using the calculator. That way you have this. You can use it at any time that you so choose. So as we begin, feel free. Use this podcast however you need to, and we'll go over some problems in class. Let's get this thing rolling, all right? Okay, so first thing I'd like to kind of do here, I'm going to pull up this. I'd like to do this here. We're going to go to, we're going to use this calculator. Let's go here to this part on this side. Okay, so what I'd like to do is just kind of walk through the process of how to do this on the calculator. And then afterwards we can kind of go off some other problems there. But let's do this as follows. So real quick, it says a projectile is fired from a cliff 200 feet above the water. Okay, and so as we look at this, the height of the projectile with the water is given by the following. And so this is where we have h of x. H of x, remember, is the height. It's also the y-axis, and you'll see that here in just a second. So we're going to go negative 0.32x squared plus x. Go over here, actually. My fault. There you go. I'm going to go come down. There we are. And then plus 200. And we are going to graph this. Now, as you see, well, actually, I'm sorry. I messed up. I think I put a, right here. Sometimes if you put a minus sign instead of a negative sign down here, well, we'll throw it off. Now, as you see here, this is kind of thrown off. So there's a couple strategies we could do. We could go to zoom. If you go to zoom fit, which is 0, you could go there and see. Well, it still doesn't necessarily get. Now, it kind of does in the sense that, as you see here, you kind of see here's the cliff, right? And it throws it off into the water, which is the x-axis. But I'd like to do this a little bit different. So what we're going to do is we're going to put for our window. We just want the first quadrant, so we're going to go from 0 to 50. Actually, that's pretty good. And then as far as the y minimum, let's go the y minimum. Let's make negative like 10. No need too much on that. And then 200 on that is good as well. I think I put a minus sign again, so we're going to put a negative here. Now let's try to graph it. And as you can see, you can kind of maybe see it a little bit better here. Okay, so the question that states here is, here I am on a cliff, right, or whoever, throwing a projectile off the cliff into the water. So you kind of see it here. So based on that, it says how far from the base of the cliff is the height of the projectile maximum. Now the key word I think of right now is maximum. So I'm going to go to second trace, and I'm going to go straight to the maximum value, which is 4. Okay. And in order to go to maximum, again, if this is the maximum about right in here, we've got to go to the left of that, right? Because left bound, make sure we kind of hit that there, right? So we're going to go right to that side, or right there, okay? So we're going to press enter on the left, and then right bound, we're going to go to the right where it kind of goes downward. And then I'm going to guess right about in the middle. And when you see this, you'll see that the maximum is 1.56 comma 200.78. Now remember that the y, or the height of the projectile, is represented, it's the y-axis. So when it asks, the first question is how far from the base of the cliff is the height of the projectile? Well, the distance from the base would be 1.56, and we're talking in terms of feet. So 1.56 feet is the length from the base of the cliff to where the maximum exists. Now, the second question asks, find the maximum height of the projectile. The maximum height would be that maximum value, which would be 200.78. So that's kind of the A and B is what we hit on there. Now, C is asking, how far from the base of the cliff will the projectile strike the water? So what we're trying to do is find where is this going to from the base of the cliff, which is here, where will it hit the water? Well, if you look at that, that's actually a 0, right? So we're going to go to 0 here, and we're going to go left bound, and we're going to go really low here. Make sure we go left would be to the left. It's got to be above that, right? So we're going to go left bound. Right bound's going to be to the right of it. And right in the middle will be the guess there, okay? And so right now you'll see that 26.61, we'll round to the nearest hundredth, is the distance from the base of the cliff to where it hits the ground. Now the next thing it asked is this. When the height of the projectile is 100 feet above the water, how far is it from the cliff? So what we're saying is when y is 100, what is x, or how far is it away from the cliff? What we can do on this one, we have a couple ways we could do it. If we were to graph just y equals 100 here, you'll notice that there's a line that cuts straight across, which means this is where the 100 mark is. So 100 feet, we're trying to find that point right there, okay? So that point of intersection. If I could find that, that's kind of where that's where my x is going to be. So if I go to second trace and go to intersect, the first one is the first curve, press enter. Second curve, press enter because it goes to the red. And then the guess comes right straight in the middle, very similar to the left bound, right bound. And you'll see that when it's 100 feet above the water, away from the cliff, it's 19.31 feet. So the distance from the base of the cliff to here, 19.31 feet. All right? All right, I'm hoping that's helping there. At least went through one of those problems. We'll maybe hit on the second one in class today. So let's go to the next one. Okay, so the next one that I wanted to hit on was the one where we are involving the rational zero test, okay? Okay, so the rational zero test is where we're going to use P over Q. Okay, let's put this right here. Oh, I'm sorry. Backwards. Let's put it here. Here we go. All right, so this is where we're going to do P over Q, right? Where it's really, if you were to write this here, would end up being, so you have negative 5x to the fifth minus 3, x to the fourth minus 11, right? While we're here, though, one thing to remember is if I were to ask you what is the end behavior of this, what would you say? Now, I know it doesn't, but let's say it did in this as well. What I could do is look at the degree. Okay, the degree is 5, right? And the lead coefficient is negative, right? Lead coefficient just means it's the number that's associated to the highest degree, which was 5. So where the degree is odd, okay, because it has an odd number, and negative, we will end up rising to the left and falling to the right, okay? And that's kind of what we'll put here as far as my end behavior goes there, okay? Now, as far as P over Q goes on this one, we know that the P, the outside number, is 25, whereas the, and that's this number here, right? Whereas the first number is negative 4. We'll just put 4 because that's all we need. So what we want to do is we want to list the factors of both. So we're going to have factors of 25 would be 1 and 5 and 25. Now on the bottom, what we have is the factors of 4 would be 1, 2, and 4, right? Now I know 2 and 2 make 4, but what we can say here, since there's any repeated values, we just put 1 in for that, okay? So what we're going to take now is we're going to put 1 over 1, 5 over 1, and 25 over 1. So what we'll have is just 1, 5, 25, okay? Now the next one we're going to do is 2 underneath 1, 5, and 25. So we're going to have 1 over 2, 5 over 2, 25 over 2. So it should look like this. 1 half, 5 halves, 25 over 2 there, okay? And the last one is over 4. So 1 over 4, 5 over 4, 25 over 4, okay? And when I list all of these here in no specific order, that would be what's called my possible zeros, or what we call a rational zero test, to determine what are the possible rational roots within this polynomial. In this example, I do not have to test any of these at all. All I need is just to list them on number 3 on the review. Okay? All right, fantastic. Let's go to this one here. Okay, I'd like to hit on we'll hit number 2 maybe in class. Let's hit on the one synthetic division where it's x minus 5/2. So what I'm going to do is I'm going to take a value, put it in here, that makes the bottom equal to 0. Well, that would be positive 5/2, right? Okay, so we're left with now 2. We're just putting the coefficients in order, right, from the highest degree down. And remember that if I don't have one, we will have to put it in as a 0. That's a big thing that people forget, okay? So we're going to bring down 2. Bring her down. Okay. We have 5/2 times 2. So if we need to, we could actually do this on the side. And we could cancel the 2's out, right? Leaving me with 5. So we'll put 5 here. 5 minus 17 is negative 12. So we'll take negative 12 and multiply by 5 over 2. 2 goes into negative 12 6 times. So negative 6 times 5 is negative 30. Negative 30 plus 56 is positive 26. So we're going to put this over here. 26 times 5 over 2, right? 2 goes in 26 13 times. And when I multiply 13 times 5, I know I'd get 65, which would produce a remainder of 0, right? So what we have now is our remaining polynomial, and this is very important. Remember that this would end up being by itself. I put an I there by itself, okay? We have an x with this one and x squared here, and it would keep going if I have more numbers. So it would be 2x squared minus 12x plus 26, and that right there would be my answer for the value that I would get when I use synthetic division, or when I divide x minus 5/2 by the polynomial on top, all right? All right, hey, let's mention number 5 real quick. That's another good one. Just want to mention it real fast. On that one, it has zeros of negative 3, 0, and 2, but it has a multiplicity of 2, so we know we're going to have 2 of those, okay? So what we have now is this. We have x plus 3, right, is produced with negative 3 as a 0. X for just 0, right? That's important. A lot of people forget that. We have x minus 2. We actually have 2x minus 2's right here, okay? So instead, what I'd like to do is just distribute kind of these 2 together and then these 2, and then I'll multiply the resultants together as well. So x times x plus 3 would be x squared plus 3x. As far as x minus 2 times x minus 2 goes, it would end up getting x squared minus 4x plus 4, okay? Now, in going forward, I'm going to multiply this out. So I'm going to go x squared to each of these 3, right, to produce an x to the 4th minus 4x to the 3rd plus 4x squared, right? Let's look at the second one. Let's multiply 3x by all 3 of them to get 3x to the 3rd minus 12x squared plus 12x. So now I'm just adding like terms, right? Only 1x to the 4th, so I bring her down. Negative 4x to the 3rd plus 3x to the 3rd would produce a negative x to the 3rd. So I got that one and that one. 4x squared minus 12x squared is negative 8x squared, and then just plus 12x, okay? And so as I figure this out right here, following below, that one right there would be the answer when I distribute that out, okay? All right. I definitely want to hit number 7. We can hit some of the I's as well. I'd like to hit the long division one I can do in class. We've hit on the end behavior already. So let me hit this last one on the front, and then we'll go to a couple on the back, especially number 9. I actually want to hit number 9 pretty good. So we'll hit that one here in a second. So let me do 3 more here as we wrap this up. We'll do 3 more. This one says that x equals 2 is a 0. Okay, so we know that if that's true, when I put this polynomial down, I should get a remainder of 0. Okay, should get a remainder of 0 right down here. So let's do this first. Let's bring down number 6. Okay, bring that 6 down. 6 times 2 is 12. 12 minus 23, or negative 23 plus 12 would be negative 11. Times 2 would be negative 22. So it'd be negative 7 and negative 14. So this actually does produce a remainder of 0, which is right because remember, if that's a 0 of the polynomial, that tells me that this remainder has to be 0. Okay. So what I can do now is I can actually take the remaining part here, and remember this is by itself, x and x squared, and what I can do is say, okay, 6x squared minus 11x minus 7. And what I'm going to do on this is I'm going to figure out maybe two things that that I could factor. So I'm trying to factor this out. Now, some of you like to do the way where you just check and guess, and that's fine. You could absolutely do that. The way I do it is A times C method, which, again, I kind of do by doing 6 times negative 7, which produces negative 42. So I'm going to hold on to that negative 42. And in holding on to that, I'm going to find two numbers. When multiplied, get me to negative 42, but when added, get me to negative 11. So I could kind of figure this out by doing, I know 6 and 7, right? Well, I'm trying to 6 and negative 7, right? That doesn't really work. I could do 221, right? Like negative, but that doesn't really work. Let's see, I could do 3 and 14. Ooh, that might work. That might be good. So remember, both of these multiply to equal negative 42, but when added, get me negative 11. So I'm going to have negative 14 and positive 3. And instead of filling in with just an x squared or whatever, I'm going to put in with 6x and a 6x. Now, part of the process is what I'm doing right here, because once I take this part, right, once I figure this out with the A times C method, right, where A and C is here, right, produce this, I'm going to say, what can I take out of 6x plus 3? Well, if I take out a 3, I'm left with x, or 2x rather, plus 1. If I take out a 2 here, I'm left with 3x minus 7. And what I have now is my two factors. The only thing that I have to do is drop the 3 and the 2, and then what I have now is 2x plus 1 and 3x minus 7. Now, if I set both of these equal to 0 and solve, that would get x equal to negative 1/2 and 7/3 there, okay? All right, awesome. What's up, y'all? Good to see you. Hey, I'm podcasting right now on this for pre-calculus because this was the study session. We'll hit on some of your questions in class. Is that cool?
Yes, I want to hear in class. Can I ask Ms. Williver?
You can, and then also I can hit on it at the basketball game.
Yeah.
We can do that. Before today, we could do it.
Yes, sir.
Awesome. Thanks, DT. Barto, you're good. You're good. Because you have questions? Come on. Yeah, you're good. DT's in Algebra 3. So I blocked this off for just y'all, okay? Right now, what I've done is, just a heads up, I have gone through, and I've just podcasted it. I've gone through all the ones on the front, or most of the ones on the front here. The ones on the back, if you have any questions on those are the ones that I haven't hit on. I haven't hit on number 9 either on that one. So if you have any questions on that, let me know, and I'll do those there. Do you have a question on number 9?
No, but you can just keep going through it, and I'll just follow along.
Okay, perfect. Good morning. What's up, Coach?
Just saying, hey.
Good to see you, man.
Doing all right.
I'm doing great. Yeah. Living the dream.
Barto, you all right, man?
Yeah, I'm good.
We'll see you, Shane. Have a good one, man. All right, so let's look at number 9 here, okay? All right, and on this one, we have f of x equals negative 3x squared plus 9x and then minus 7, okay? And especially on this one, I know some people had some problems on this when we went through it in class, so I want to make sure I hit on it. We're trying to get it from standard form into vertex form. And I'll give this to you, so you'll have this, but we'll have a times x minus h squared plus k right there, okay? So I've got this here, and what we've got here is a is negative 3, okay? And what we're going to do is we're going to plug negative 3 in for a. So that we know is consistent. So the a's are always going to be the same within this vertex form here, okay? Now, as far as the vertex goes, h comma k, we can find what h and k are by doing the following, by doing negative b over 2a, comma, and then f of negative b over 2a. We will need to know this formula for the test. That's the only one that we need to know, okay? All right, so we could plug in b, which is 9. So we have negative 9 over 2 times negative 3, which was a. And once I get this, I'll have negative 9 over negative 6, which when reduced produces 3 over 2, okay? So this is the h right here. So what we have now is we just plug 3/2 in for that h. All right, now rewrite this, but just a heads up. Now the last thing we need is the k. It's probably the toughest part because we have to actually plug it into our formula here. And so what we have now is f of x equals negative 3 times 3/2 squared plus 9 times 3/2 minus 7, okay? So 3/2 squared would be 3 squared, and it would be 9 over 4 times negative 3, right? And 9 times 3 is 27. So we have 27 over 2, and then minus 7 at the end. With the negative 3 times 7 over here, we get negative 27 up on top on this one. The only problem is we don't have common denominators. So if I come back here, I want to produce a 4 here and a 4 here. So I'm going to multiply this by 2 to get 4, and this by 2 to get 54. Okay? Multiply the bottom here by 4 on this side. Multiply the top by 4 to get 28. So what we have is negative 27 over 4 plus 54 over 4 minus 28 over 4. It's kind of a lot of mess, but we ended up kind of just doing the top because we know the 4 is going to stay consistent on the bottom. We have 28, 27 make 55. So negative 55 plus 54 is negative 1 over 4. So this is negative 1/4. So if I were to rewrite this, I'd have y equals negative 3 times x minus 3/2 squared minus 1/4. Okay? You have any questions on that?
So that whole part on the bottom right, that was you finding the y of.
That's correct. Yeah, so 3/2 is here, right?
Mm-hmm.
The f of negative b over 2a just means that I take 3/2
And plug it back into the
and plug it back in, yeah.
And then that just gives you negative 1/4. And
Negative
then you just
1/4,
rewrite it.
yep, and then that's it.
All right, that's easy.
It's good. It's good. All right, so do you have any other questions on there? On other ones? Just trying to think. One of the things to just put on the podcast too is x-intercept, like on number 12, is like with x-intercepts and y-intercepts. I don't think you have the problem with this, but just remembering that if I have the x-intercept, I plug 0 in for y.
Mm-hmm.
And if I have y-intercept, I plug 0 in for x, right?
Mm-hmm.
So that's just a heads up when I solve this here. One of the ones that, again, the y-intercept's pretty easy. If I plug in for 0, I just solve it. The one that really gets people is the x-intercept. So if I plug 0 in for y or g of x here, I have 0 equals kind of negative 4 times x plus 3 squared plus 5. And to solve this, we're going to subtract 5. And when I do that, then I have negative 4 times x plus 3 squared. I'm going to divide by negative 4. So I have 5 over 4 equals x plus 3 squared. Now, here's where a lot of people mess up. When they solve that, what do you think we do here, by the way, to get x kind of by itself?
You'd square root.
Yep. And so when I square root that, I do it to both sides. What happens over here? If I square root a square, this will turn into plus or minus.
Okay.
Plus and minus. So we would actually have, and we could simplify the top. So we'd have the square root of 5 over, and then the square root of 4 would end up being just 2, right? So we'll have 2 on the bottom. Okay. So square root of 5 over 2 plus or minus. And then what I can do is actually subtract 3 on both sides. So plus or minus square root of 5 over 2, and then minus 3. And we'd leave it just like that. So x is equal to plus or minus square root of 5 over 2, and then minus 3. That would be our x-intercepts. And I guess you could kind of get a decimal. I would probably give either or on that. Now, I probably would want it in that form, right there, for this one specifically. All right. Does the y-intercept, is that pretty easy? That's the easy one where you just plug in 0, right? Plus 3, square it, multiply by negative 4, and add 5. All right. Do you have any other ones, Barto, at all?
maybe like, oh, have you already done the front ones?
Some of them I haven't.
Maybe like 6 or something.
6 I have not done. Yeah, let's do that one. So this one, I'm gonna actually pull up the calculator for this one. But before I do that, I'm actually gonna go. I'm gonna go back here, and we know that R of P is the equation. That's our revenue, right? That's our revenue there. It equals -1/2 P squared. Okay. So -1/2 P squared, and plus 1900 P, right? So we're gonna use this equation where R is the revenue, right there. R is revenue, and it says what unit price would be associated with the revenue of 200,100. Okay. Well, we know the unit price is P, right? So we know that that's true. Okay. And because of the fact that we were given this, what do you think 200,100 would go into?
R.
Yeah, we literally plug it in. Good. So we're gonna have 200,100 equals -1/2 P squared plus 1900 P. Now, what are we trying to solve for in this?
What the unit price would be at that price.
Good. And so we're really putting it as P, right? Well, since this is P squared, we're going to subtract this 200,100 on both sides to where we kind of set it equal to 0. And what we're going to do is we're going to solve for the unit price P with utilizing this equation, all right? So we're just going to solve this. Now, to solve it, though, I'm going to kind of hold this up here. Let's see here. All right, let's do this. Plug this in. Okay. Take these off. So what we're just gonna plug this in, and once we plug it in, we should get where the x-intercept is. That's where we would solve for P. And then it's plus 1900. And then minus. What we're going to do is graph this right here. What's up, Bryce? Now you see it's kind of off from my graph, so I'm going to go to zoom fit. Just going to check it out. Now it doesn't help me out hardly at all. So what we can kind of go to is I want to go to my window and see that, okay, my max 0 to 50 is fine, but this right here is a little off. I want it to be a lot better than that. So what I'm going to kind of change up is this. I'm going to go, we'll go from -100 to 100. Let's just check it out. Let's see if this will work. Still didn't, so let's try to do zoom out a little bit. Okay, we see right here that there's something right here, right? Now we could keep zooming out. Let's see if we zoomed out, if we get a little clearer picture. And you'll kind of see what's happening. It's kind of going like this, right? And it's probably way over here. Now, this spot right here, we know where it hits the x-axis is our P value, right? Our unit price. So because of the fact, even though it would be nice to be able to see it, we know that that's our answer. So what we're going to do is we're going to go to 0, and we're going to go left bound, which if I were to do it, I want to make sure that this is negative here, that y is negative. So when we do it, let's see if we can actually see the cursor here. See how it went from negative right here to then a positive, right? We want the negative value because that's to the left or below it, okay? So we want to press enter there. Now as far as the right bound, we want to get it where it's above, so where it's positive. And then in the middle, we'll hit on the middle to produce an answer of 108.41. And again, that would be then the unit price that's there. You also will have another x-intercept, which will be on this side. but we can't have that because that's a negative unit price, so that wouldn't make sense. So it would be the value that would be on the positive side. Okay. Awesome. Well, those of you on the podcast, thank you so much for joining us, making sure you're studying up. We'll hit some up in class, and hope you have a good day. Look at Luke. Give a shout out to Luke and John's there. All right. See y'all. Bye.
Yeah.